Hi guys, it's Miss Griffin. We're taking a look at Unit 8, Skill 2. Last video you guys learned about properties of shapes, and today we're going to learn how to use those properties to prove shapes with coordinates. So your essential question for this skill is, how do we prove shapes with coordinates? So you can see here that we have a sample coordinate proof. So in the end, this is what your product will look like. You have a statement here given quadrilateral FGHJ with coordinates F, G, H, and J. Prove that it's a rhombus. So if you think back to the properties you learned with Miss Wesley, a rhombus has 4 congruent sides. So your first step is to come up with a plan. What's necessary to prove the particular shape? Then your second step is to make a huge, gigantic chart. Okay, so you guys are used to the chart with change x, change y, Pythagorean theorem, and slope. And just as a reminder, Pythagorean theorem represents length. You can find the length of a segment by using a squared, b squared, c squared. And then change y over change x, again, y is to the sky, represents your slope, where you can find the rise over the run of a given segment. So once you make your big chart, you find your change x's, your change y's. Again, you can use the graph. So if, say, I was doing FG, my change x would be over 1, and my change y would be up 4. That's where these 1s and 4s are coming from. Now, if I were doing a different segment, then I would use a different set of numbers on the graph, like 1 and 4 for JF, so on and so forth. Or you can do it algebraically, like I know a lot of you like to do, where you take your coordinates and you stack them, F and G, so 3, 4, 2, 0, and then you subtract your x values and you subtract your y values. Whichever method you prefer, stick with it. Okay, so you don't have to change gears just because we're in a new unit. Stick with what you know. So now, if I'm looking at my big chart, I want to circle any findings in your chart and write yourself little notes. These are going to be called your conclusions in the table. So you make conclusions within the table, and then you make conclusions out of the table. I know it sounds like a lot, but trust me, it's not so bad. If you have a marker or a highlighter, I'd like for you to grab that right now, because I want you to make sure that you are seeing these conclusions. We have square root 17, square root 17, square root 17, square root 17. Whoa, fabulous. But now if I'm looking at each of those, that means that each side of this rhombus is congruent to one another, or are congruent to one another. Okay, so that's my first conclusion. Then I take a look at the slopes and I see, again, grab a highlighter or something so that you can highlight or circle these things with me. I see 4 over 1 and I see another 4 over 1. So those pair together. If slopes are the same, listen to this, if slopes are the same, the lines are parallel. Cool. Now I got another one where I see 1/4 and 1/4. Those are the same. So again, I'm going to pair them together. Same slope means lines are parallel. So I just made 3 conclusions in my chart based on the Pythagorean theorem and slope. Not based on change x, change y, because that doesn't matter. What matters is the length of the side and the slope of the side. So now I'm going to say, final conclusion, that FGHJ is a rhombus because there are 4 congruent sides. That's what I noticed here. I could also say that opposite sides are parallel. And really, if you're not sure about the shape, then conclude everything that you can in the table and in your final conclusion. Okay, so hang on. Let's go back and number some of these steps because I kind of lost track of that. We have step 3 right here where we're making these little conclusions, and step 4 is the final conclusion. So now we're going to talk more specifically about step 3. If the lengths, being a squared plus b squared equals c squared, are the same, then the segments must be congruent. If the lengths are the same, the segments are congruent. We've talked about that before. Same length means equal in measure, which is the same as congruent. If slopes, that's your change y over change x, are the same, then the segments are parallel. But what if the slopes are opposite reciprocals? They're no longer parallel, but perpendicular. And perpendicular lines, remember, make right angles. So there is a right angle. Sorry about my grammar. So those are the little conclusions you would make in your table. You would make those curly brackets, and then you'd say congruent. Or you make curly brackets and you say parallel. Or you make curly brackets and you say perpendicular, depending on what you can find in your table. Then we have conclusions outside the table. You would say ABCD is a rhombus, rectangle, parallelogram, square, isosceles, triangle, whatever it happens to be, whatever the shape is. It's a blank because I found this in my table. There are two pairs of opposite sides parallel. There are perpendicular lines forming a right angle at angle B. Or whatever it happens to be, you use the properties. Okay, so we're going to get practice with this as soon as we take a look at the properties one more time, because we got to get these properties stuck in your head in order for you to be able to do these proofs. So flip it over. We're going to deal with some properties, and then we'll do some examples. Properties of quadrilaterals and triangles refresher, because don't forget you got this in the first video. So it says when concluding the type of parallelogram from a table or type of triangle, you must know the basic properties of these figures. Sometimes more properties are concluded from the table, and those properties are noted in parentheses. So basic properties are what you see immediately following the shape, and then additional properties are what you see in the parentheses. Okay, you don't have to underline those. I'm sorry for doing that. So here it says that a parallelogram, we know basic property is that opposite sides are parallel. But we also know that opposite sides are congruent. A rectangle, if you recall, is a parallelogram that has opposite sides parallel and a right angle. But don't forget, opposite sides are still congruent. A rhombus is a very special parallelogram where all four sides are congruent. But again, opposite sides are parallel. Now, a square, if you think of your PRRS that Wesley was talking to you about last video, your PERS, you have parallelogram breaks down into rectangle or rhombus, but rectangle and rhombus together make a square. So a square has all those properties from up above it, which means that it has four congruent sides and a right angle, but opposite sides are also parallel. A trapezoid is that weirdo shape that has one pair of sides parallel. An isosceles triangle is a really special one where that one pair of sides are parallel, but the legs are congruent. Maybe you want to draw those pictures with me and then draw an arrow to what each one was. A right triangle, hopefully that one's not too hard for you. A right triangle has one right angle. And then I want you to take a second, just fill out those three, scalene, isosceles, and equilateral, and then check your answer with mine, please. Scalene triangle, three sides are not congruent, right? That's where the triangle has three different sides. Isosceles is where there are two sides congruent, and equilateral, of course, has three. Okay, so let's take a look at this example number 1 where we have to actually do the proof ourselves. Given a triangle with coordinates A, B, and C, take a second, pause your video, and plot that. Okay, so I'm sorry, mine's super messy. It's hard to plot this on an iPad. So here it says we have to prove that the triangle is right and that it's isosceles. So a right triangle, this is our plan, step 1. Right triangle has a right angle, of course, which comes from perpendicular lines. And those lines come from op, recip, slopes. Then the isosceles triangle part comes from having how many congruent sides? 2 congruent sides. And that comes from length. So guess what? We're creating this huge table to find length and slopes so that hopefully we have 2 congruent sides and opposite reciprocal slopes. P.S. They're not going to tell you to prove it's a shape and then you find out that it's not. So you can never do this huge table and say, oh no, they're wrong. It's not a right isosceles triangle. They're wrong. Nope, sorry, it's you that's wrong. They're telling you to prove that it is this, and so you have to find the work that's appropriate to show that it is what it is, okay? So here, we started this table for you just to save you a little bit of time, but I promise you it will never be started on your test for you. So here we have AB, BC, and AC, and I listed the coordinates for you because it makes your life easier. Take those 30 seconds that it does to list out your coordinates. So first column, change x, second column, change y, a squared plus b squared equals c squared, and change y over change x. Again, y's to the sky. So this is step 2. We're making our huge, gigantic table. I'll start you with AB, but then I want you to pause the video and do BC and AC because you guys have been doing tables for the past unit and a half now at this point. So change x means that I take my x's and I subtract them. 2 minus negative 2. And that gives me positive 4. Then I take my y's, let me find a different color here. Take my y's and subtract them. Negative 1 minus 1 is negative 2. Then I plug those into Pythagorean theorem, but remember that we don't care about negatives for Pythagorean theorem. So I have 4 squared plus 2 squared equals c squared. So then I have c squared is equal to 4 squared is 16, 2 squared is 4, so 20. 16 plus 4. You can use a calculator if you want. Then I have to square root both sides, so c equals square root 20. And I leave it, because it doesn't say anything about simplest radical form. And then slope is change y, which was negative 2, over change x, which was 4. But I know that that can be reduced to negative 1 over 2. Okay, so you just saw me go through AB. I want you to go through BC and AC and then check your answers with mine. So pause the video while you do that, work them out, and then hit play when you're ready to see answers. Okay, so you can see that I found some distances and slopes. I have BC to have a distance of square root 20, or a length of square root 20. And guess what? You notice that I didn't put that middle step in there. That's okay for you to do too. Okay, so if you find out that 2 squared plus 4 squared is 20, and then you know you have to take the square root, you're okay to write your answer as c equals square root 20. Okay, so skip that middle step is fine. For AC, I found length to be square root 40. For BC's slope, I found it to reduce to 2 over 1. And then for AC's slope, I found it to reduce to negative 3 over 1. So now we're about to take on step 3, where we make some conclusions. So you look at this column here, and you say, okay, what do I notice? Square root 20, square root 20. Fabulous. So step 3 is making these conclusions. So you want to grab a colored marker or a pencil or a colored pen, something different so it stands out to you, and lump them together, group them, and say that, okay, these are each square root 20, so that's like, I don't know, 4 point something. Each of these lengths, BC and AB, are 4 point something. So what does that mean? Well, that means that they are congruent. You have to make this very clear on your table. If I can't see it on your table, I can't give you credit for it, okay? Then I take a look at my slope column, and I say, all right, what can I find here? Well, I see a negative 1/2, a positive 2 over 1, and a negative 3 over 1. So this guy seems like the oddball out, but what if I look at this again for one more second? Negative 1/2, positive 2 over 1. So the 1 over 2 got flipped, and the negative became positive. Don't you recall that if we flip and negate, then the lines are perpendicular to one another, right? Because that's what opposite reciprocal means. So I'm going to take this, and I'm going to take this, and I'm going to pair them, again with a colored marker, and say that they are perpendicular. So that was step 3, conclusions in the table. Oh no, this isn't going to let me scroll. Okay, so I'm just going to have to write really tiny, but you can use the space at the bottom of your paper. Step 4. Triangle ABC is an isosceles right triangle because Well, first we found two congruent sides, and there are perpendicular lines forming a right angle at angle. So it was AB, which is perpendicular to BC. They meet at angle B. So at angle B, forming a right angle at angle B. Sorry for the messiness, I couldn't scroll. Okay, so let me just recap. We made a plan, step 1. Step 2 was the huge chart. Step 3 was any conclusions that we could make, congruent, parallel, perpendicular. And step 4 is your final conclusion about why it is what it is. All right, so flip it over and we're going to see proving a quadrilateral. So we just did triangle, now we're going to do quadrilateral. Prove quadrilateral ABCD. It has coordinates, blah, blah, blah. Prove that it's a square. All right, so before we go anywhere, let's pause, plot your points, and then make your huge chart. And then we'll figure out what our plan is and how we're going to get there. Okay, so I've plotted, and I'm going to make the huge chart in the biggest amount of space that I see here, which happens to be in this area. So I know that I'm going to have AB, and I'm going to stack my letters, -3, -2. Not letters, these are numbers, I'm sorry. -1, +2. And then my next one is BC, and that's -1, 2. 3, 0, and then AC, nope, I'm lying, CD, sorry, you're going around your figure, AB, BC, CD, which is 3, 0, and 1, -4, and then last but not least, DA, which is 1, -4, and -3, -2. So then I have change X, change Y, A squared plus B squared equals C squared. I'm going to keep that column kind of big because it helps you when you make your conclusions. Then you have space for it. And then Y is to the sky. Change Y over change X. Okay, so that's just your basic setup. We'll fill it in a second because we got to go back up top to step 1. Step 1 is figure out what do we need for a square. What's special about a square? Well, you know that there are 4 congruent sides. So that means we're going to need length. And there is a right angle, not a rectangle, a right angle. A right angle comes from perpendicular lines, which means we're using slope. All right, so again, I'll start you with AB, but then I'm going to have you guys fill in the rest of the chart yourselves, then we'll make some conclusions together. So AB, I'm going to take my x's and subtract them, -3 minus -1. Double negative turns to positive, so that becomes a -2. Then I have -2 minus 2 for the y's, which becomes -4. Now, if you are looking on a graph and you are doing your change x and change y graphically, you have a rise of 4, so that's +4 for your change x or change y, and a run of 2, so that's a +2 for your change x. It's okay if you get different values algebraically versus graphically, as long as your slopes come out the same in the end. Okay, so algebraically, my slope would be, I'm just jumping over Pythagorean theorem for a second, -4 over -2, which reduces to +2 over 1. If I did it graphically, my slope would have started with 4 over 2, which reduces to 2 over 1. Wow! Okay, so I'm just going to erase that little bit of work there because I don't need it. I only need it once. But I am going to jump back to Pythagorean theorem. We have 2 squared plus 4 squared equals c squared. 2 squared and 4 squared, we just did this the last time, is 20, but remember you take the square root of both sides, so we have square root 20. Okay, pause your video, fill out B, C, C, D, and AD, and then hit play when you're ready to see answers. Okay, so pause the video so that you can check your answers with mine. They're obviously going to stay here, but hit play and go through conclusions with me when you're ready. Okay, and so PS, I know all of these came out to be square root 20 because you were adding the same numbers when you squared them. And some of you were probably like, oh my gosh, I want to just be lazy and not have to write this out a million times. But I'm sorry, you have to write it out each and every time. Okay? So let's make some conclusions. We see square root 20, square root 20, square root 20, square root 20. Fabulous. If all of them are equal to square root 20, do you conclude that they're parallel, congruent, or perpendicular? Those are your three and only three options. Well, they're all the same length, which means that they are congruent to each other. So big curly bracket, congruent. Again, use a colored marker so that this stands out on your picture. Okay, grab a different color marker, or the same one, I guess, it doesn't matter. And I notice that I see, 2 over 1 and 2 over 1. That's cool. Same slope means that they are parallel. Then I see negative 1/2 and negative 1/2. Again, same slope. That means they're parallel. But we didn't want just parallel and just congruent. There's one more thing that we can find in this table. And hopefully you see that we have a positive 2 over 1 right here and a negative 1 over 2. Positive 2 over 1, negative 1 over 2. Those were flipped and negated to make our fabulous and beautiful perpendicular lines, which we need. Perpendicular lines make a right angle. All right, so that was step 3. Step 3 was those little conclusions. And then step 4 is our final conclusion. Why is ABCD a square? So step 4, ABCD is a square because 4 congruent sides and perpendicular lines forming a right angle at, and in this case, I took AB and said it was perpendicular to BC. The common letter here is B, so the angle is at B. Now, if you had concluded down here that these were opposite reciprocals, which is true, then you would say your right angle is at D. You do not have to conclude every pair of opposite reciprocals. Okay, you only need to pick one pair of opposite reciprocals and say that they're perpendicular. Because if one angle is a right angle, then the rest of them are right angles as well. You do not have to number your steps either. That was me going through that so that you could compare it back to the steps that you saw on the first page. You also made a conclusion here about opposite lines that are parallel, and you could say that, and op sides are parallel, but it's not necessary. If you don't know why the shape is what it is, then you conclude everything. And maybe we should write that note off to the side. If you don't know how to prove a particular shape, show and conclude everything you can from the table. All right, so you've got your basics here. You are making huge, gigantic charts, which are not hard. They just take some time. Okay, so don't complain. Don't be complainers because you are fully capable of doing this work. Okay, let your teacher know if you have any questions. If you need to rewind and go back, please do. Otherwise, good luck and let us know if you need any help.